And so here's your 5.2 homework. And let's see here, what looks interesting on this one? I always get asked about number 2, so I'll just let y'all ask me about that Monday probably. 3 is kind of interesting. Use your x to the p over r as you do this. And it'll make it where you can actually maybe simplify it a little easier. But now the goal here is one simplified radical. That's the goal. So initially I'm going to think of this as 3 to the 1/3 times 3 to the 1/4. All right, it's all to the 12th. Okay, I'll save that for later. Now, if I have like terms, I can add exponents. I need to think about what 1/3 plus 1/4 is. Well, those two are going to have, actually, I don't even need to be worrying about this because when I distribute the 12, those are going to disappear, so never mind. 1/3 of 12 is 4, and 1/4 of 12 is 3. So this one doesn't even need a radical. This is 3 to the 7th, which is a pretty good sized number. I'm not even sure what it is off the top of my head. Guess we'll find out. Maybe we'll find out. That's why it's on my pixel. Anyway, so what was that? 3 to the 7th, 2187. So that one wasn't too bad. Let's look at 4. 4 is a tough one. A long time ago, 500 years ago, somebody said never a radical in the denominator. Now, I'm not that guy, so don't hate me. This one actually is not as bad as I'm looking at it. I can think of this as 128 over 2, since they're both 5th roots. So this is going to be the 5th root of 64. Now, in class, I know we've done the 5th root of 32. 5th root of 32 is 2. Or at least we've done 2 to the 5th or something along those lines. So I can think of this as 2 times 32. And the 5th root of 32 is 2. So 2 5th roots of 2 is a simplified radical. All right, moving forward. Actually, I'll do that one. This is division of exponents. Sorry, division of like terms with exponents. And it becomes an idea of subtraction or simply moving things around. You can also use your x to the negative n idea. But, look at this one. The easiest thing to do might be to move that 9 to the negative 4/5 up top and make it positive. Now, I need to figure out what 1 plus 4/5 is. 1 is going to be 5/5, and 5/5 plus 4/5 is 9/5. It's 9 to the 9/5. Now, I want a simplified radical if needed. And I do need a radical here. This is the 5th root of 9 to the 9th power. That's what it is. If you want to figure out what 9 to the 9th is, by all means, go ahead and do it. I'm not. All right, so it's like take 3 on this problem because I'm apparently having mental issues today. Let's look at this thing as exponents. This is 4x squared all to the 1/6 times 2x to the 1/3. Now, it's kind of funny how exponents work and radicals work, but I need these to be the same. They have to be the same, and they're not. So what we're going to do is we're going to change 1/3 into terms of 6. 1/3 happens to be 2/6, last I checked. And there's the bell, already behind. What we can do is we can move this 2 on in. So we have 4x squared to the 1/6 times 4x squared to the 1/6. And now we have like radicals. We have the 6th root of 4x squared times the 6th root of 4x squared. And we can actually multiply the stuff inside. 4 times 4 is 16. X squared times x squared is x to the 4th. And it's all under a 6-degree radical. All right, that one's finally out of the way. Let's see here. 9 We have 2 over x to the 3/2. So what's the issue with this one? The issue with this one is when you initially do your rewrite, power over root, you have the square root of x cubed. That's the issue. Now, normally you would just, and it's actually not a big issue with this one, you could just multiply top and bottom by root x cubed, and you'd be all right, I think, on this one. But it'd be more work than you need. I know that the square root of x to the 4th is x squared. And I know that the square root of x cubed times the square root of x is the square root of x to the 4th. So I'm thinking a step or two ahead about what I need. I'm actually just going to multiply by the root of x and be done with this thing. That'll give me 2 root x up top in the numerator and the square root of x squared, sorry, to the 4th down low. Remember, we have an understood 2 right here. So 4 over 2 is 2. 2 root x over x to the 2nd. So those are always fun. Not really. All right. Number 10, we've got some addition going on, some things we're supposed to do. This one shouldn't be too terribly bad. We'll just distribute that half and see what happens. We distribute that half, we'll have x squared y to the half. We distribute that 2, we'll have plus x squared y to the half. And these are like terms. There's 2 of them. So it's 2x squared y to the 1/2. 12's up next. You got 4th roots, both the same radical. That's nice. So when the radicals are different, that things get a lot rougher. And let's just see what we can do. 32 is 16 times 2. There's an x to the 6th, 4th root, so x to the 4th, x squared. And there's still a y out front. 162 is 81 times 2. We have an x squared, y to the 4th. And let's start evaluating. The 4th root of 16 is a 2. All right, not worried about that thing. The 4th root of x to the 4th is an x. And I have my y from previously. That leaves me with a 2x squared on the interior. So moving on, the 4th root of 81 is 3. I cannot take the 4th root of x squared, but I can take the 4th root of y. So that gets there. And what do I have left inside? I have 2x squared. There's really not a whole lot you can do with this because these pieces don't match. If you want to get creative and feel special, what you can do is you can say that this is 2xy plus 3y times the 4th root of 2x squared. You can say that. You can think about the common factor, but that's about as far as you can take that one. All right. Just because this is the FOIL technique. 3 root p times root p is going to be 3p because a radical times itself is a number inside. 3 times 5 is 15. And a root of p times a root of 5 is going to be a root of 5p. Moving on to the interior. So that was plus 15, right? Here we have a root of p times a negative root of 5, so minus root 5p. And now to the end. A root 5 times root 5 is 5, times that 5 is 25, and there's a positive times a negative, so minus 25. Cleaning up like terms, we have 15 minus the understood 1, so 14 root 5s of p and minus 25. Fun stuff, huh? Radical simplification. The idea here is to use the conjugate. And the conjugate of 3 plus root x is 3 minus root x. And what we're going to do is we're going to FOIL the bottom. We're going to have 3 times 3, which is 9. 3 times a negative root x, which is minus 3 root x. 3 times a positive root x, which is plus 3 root x. And then root x times negative root x, which is minus x, because a radical times itself is the number inside. The top is nothing more than the distributive property, minus 6x minus 2x root x. And let's start canceling some stuff out. We have negative 6x minus 2x root x sitting pretty over 9 minus x. And this is supposed to be pretty. This is apparently the pretty version. I don't agree with that, but I do understand why we teach it, because it's important to understand the ideas of conjugates as you move forward into calculus and so forth. So I get why we teach that in mathematics. Let's see here. I'll do one more of them for you on this one. The conjugate of 2 take away 2 root 8 is 2 plus 2 root 8. And we're going to do the same idea here. We'll FOIL the bottom. 2 times 2 is 4. Then we'll have plus 4 root 8. Then we'll have minus 4 root 8. That's the beautiful thing about the conjugate, is these pieces always cancel out. And then we're here. 2 times 2 is 4. It's negative. And root 8 times root 8 is 8. See, Michael? Yeah. And that's going to be negative 32. So 4 minus 32 is negative 28. Up top, we're going to have to FOIL, and this is just going to be plain old ugly. 3 times 2 is 6. Plus 6 roots of 8. Plus 2 roots of 8. And then plus 16. And there's going to be some simplification here. 16 and 6 makes 22. 6 and 2 makes 8. And we're sitting over a negative 28. All right, so what does everything have in common? It's divisible by at least 2. And we're going to move the negativity up top. So we're actually going to divide everything by negative 2. 22 over negative 2 is negative 11. 8 over negative 2 is minus 4. And then negative 28 divided by negative 2 is 14. And that's number 18. The last one I'm going to do is going to be 20. The opposite of a square root is a square, kids. And if you square a square root, you get the quantity inside. We're going to add 4 to both sides. So 2x is 40. Divide by 2. And my x value is 20. There you go.